For billions of years, Earth has been doing something so ordinary that we rarely stop to think about it. It spins. Every second of every day, our planet rotates around an invisible axis running from the North Pole to the South Pole. We don't feel it. We don't hear it. We don't see it happening. But Earth's rotation controls some of the most fundamental patterns of life on our planet. It helps create day and night. It influences winds and ocean currents. It affects weather systems. And it contributes to the conditions that make Earth such a remarkable place for life. But imagine something impossible.
Imagine that. For just 5 seconds, Earth suddenly stopped rotating. Not gradually, not over millions of years, but almost instantly. The planet stops. Then, 5 seconds later, it starts rotating again. Would anything happen? Would people notice? Would oceans rise? Would buildings collapse? Or would those 5 seconds pass almost unnoticed? The answer is one of the most fascinating thought experiments in planetary science. And the first thing we need to understand is that Earth is not standing still right now. At the equator, Earth's surface is rotating at roughly 1,670 kilometers per hour, or about 1,040 miles per hour. You are already moving at incredible speed. You just don't feel it because everything around you is moving together. The ground beneath your feet, the atmosphere above you, the oceans, the buildings, the trees, the cars, and even your body. Everything is participating in Earth's rotation.
Now imagine Earth suddenly stops. The ground stops. But everything that was moving with the planet would still have momentum. And that is where the real danger begins. Physics gives us a simple rule. An object in motion tends to remain in motion unless another force changes its movement. So if Earth's surface suddenly stopped rotating, the atmosphere would not necessarily stop at exactly the same moment. The oceans would still have momentum, and everything that was not firmly attached to the ground would continue moving eastward. At the equator, that motion could be more than 1,000 miles per hour. Imagine standing outside when the ground beneath you suddenly stopped moving. You would not simply remain standing there. You, along with the air around you, would still be moving at Earth's previous rotational speed.
The result would be catastrophic. But there is an important detail. Earth would not actually be able to stop instantly through any known natural process. The amount of energy and torque required would be unimaginably enormous. So this scenario is purely hypothetical. Scientists use thought experiments like this because they help us understand how physics works. And if we temporarily ignore the impossible mechanism that stops Earth, we can explore what the consequences would look like. The first major effect would be the atmosphere. The atmosphere rotates along with Earth because Earth's gravity and friction keep it moving with the planet. If the solid Earth suddenly stopped while the atmosphere continued moving, enormous winds would develop. Near the equator, these winds could theoretically approach the previous rotational speed of Earth's surface. That means winds potentially exceeding 1,000 miles per hour. For comparison, some of the strongest hurricanes ever measured have produced sustained winds of around 200 miles per hour. Now imagine winds several times stronger. These would not behave like an ordinary hurricane. They would be a planet-wide atmospheric catastrophe. Buildings would be destroyed. Forests would be flattened. Infrastructure would be devastated. Dust, debris, and enormous amounts of material could be carried through the atmosphere. But the atmosphere would not be the only problem. The oceans would also continue moving. Water has mass, and water has momentum. If the planet stopped rotating suddenly, enormous quantities of ocean water would continue moving across the surface. Coastal regions could experience devastating flooding. The Earth would not have time to completely reorganize its atmosphere and oceans in only 5 seconds. But the initial effects could still be extraordinarily destructive because the starting velocities are so enormous. The consequences would depend on exactly what Earth stops rotating means. If the solid planet suddenly stopped, but the atmosphere and oceans continued moving, the surface environment would experience extreme forces. If somehow the entire Earth, including the atmosphere and oceans, were magically stopped together, the situation would be very different. There would be no enormous relative motion between the ground and atmosphere. But the physical mechanism required to stop every part of Earth simultaneously would violate the assumptions of the thought experiment. In other words, there is no realistic way for the entire planet to simply press a pause button. Still, let's imagine that somehow everything stops together. For 5 seconds, there would be no rotation. The sun would still appear to move across the sky because Earth would still be orbiting the sun. But the normal progression of the sky would briefly change. Then, after 5 seconds, Earth would begin rotating again. And once again, the problem would be momentum. Restarting Earth's rotation instantly would create enormous forces. Anything not moving exactly with the Earth's surface would be thrown into motion relative to the ground. The atmosphere and oceans would once again be subjected to tremendous acceleration. The Earth's crust would also experience extraordinary mechanical stresses. Earthquakes could potentially occur. Tectonic systems could be disturbed. But the exact consequences are impossible to calculate without specifying how the stopping and restarting mechanism works. And this is an important lesson. The phrase, "Earth stops rotating for 5 seconds," sounds simple, but scientifically, it hides a huge number of questions. Does the atmosphere stop? Do the oceans stop? Does Earth's core stop? Does the moon's gravitational influence change? Does the planet restart instantly? How does the energy disappear? Where does that energy go? These details completely change the outcome. There is another fascinating consequence. Earth's rotation slightly affects the shape of our planet. Earth is not a perfect sphere. It is slightly wider around the equator than from pole to pole. This is partly because rotation creates a small outward effect. If Earth stopped rotating permanently, over extremely long periods, the planet's shape would gradually adjust. But 5 seconds would be far too short for Earth to physically reshape itself in any major way. So the biggest immediate danger would not be Earth's shape. It would be momentum. The world around us is already moving at extraordinary speeds. We simply don't notice because we are moving together. That is one of the strangest facts about life on Earth. You may be sitting completely still right now, but if you are near the equator, you are traveling around Earth's axis at more than 1,000 miles per hour. And at the same time, Earth is orbiting the sun at roughly 107,000 kilometers per hour. The solar system itself is moving through the Milky Way. So even when you feel motionless, you are actually part of several enormous cosmic motions happening simultaneously. That is why stopping Earth's rotation would be so dramatic. The danger would not come from the planet suddenly losing gravity. Gravity would still exist. It would come from the fact that everything on Earth is already moving. 5 seconds may sound insignificant, but when an entire planet is rotating at hundreds or thousands of kilometers per hour, even a few seconds could matter enormously if that rotation were changed suddenly. You are actually part of several enormous cosmic motions happening simultaneously. That is why stopping Earth's rotation would be so dramatic. The danger would not come from the planet suddenly losing gravity. Gravity would still exist. It would come from the fact that everything on Earth is already moving. 5 seconds may sound insignificant, but when an entire planet is rotating at hundreds or thousands of kilometers per hour, even a few seconds could matter enormously if that rotation were changed suddenly. Fortunately, there is no known natural process capable of suddenly stopping Earth's rotation for 5 seconds. Earth's rotation does change naturally, but extremely slowly. The moon's gravitational interaction with Earth gradually slows our planet's rotation over immense periods of time. The change is tiny, so tiny that humans would never notice it from day to day. Earth will continue spinning. The sun will continue rising and setting. The atmosphere will continue moving with the planet. And the oceans will continue following the rhythms of a world that has been rotating for billions of years. The thought experiment teaches us something much bigger than what would happen during 5 seconds of darkness or chaos. It reveals how much of our everyday existence depends on motion. We live on a moving planet. We travel through space without feeling it. And the stability we experience every day exists because enormous physical systems remain in balance. Earth doesn't need to stop for 5 seconds to remind us how powerful motion can be. All we have to do is look at the world around us and realize that beneath our feet, an entire planet is spinning through space. And if that motion ever stopped suddenly, even for just 5 seconds, the consequences could be far more violent than anything humanity has ever experienced. And perhaps the most fascinating part is what would happen after those 5 seconds. If Earth suddenly began rotating again, the danger would not simply disappear. Everything around the planet would once again need to accelerate to Earth's enormous rotational speed. The atmosphere, oceans, and surface would experience tremendous forces as motion returned. For humans, this would be a reminder that Earth's rotation is not just an astronomical fact. It is part of the delicate system that makes our everyday environment possible. We rarely notice Earth spinning beneath us, but if that invisible motion suddenly changed, even for a few seconds, the world we know could be transformed in an instant. Earth's rotation may feel invisible, but it controls our world. If it suddenly stopped, even briefly,
One of Jupiter's most iconic features is the Great Red Spot, a gigantic storm that has been raging for over 350 years. First observed in the 17th century, this storm is so massive that Earth could fit inside it. With wind speeds exceeding 400 miles per hour, the Great Red Spot is the largest and longest-lasting storm in the solar system. Although the storm has been gradually shrinking in recent decades, it continues to captivate scientists and space enthusiasts alike. Its reddish color is thought to be caused by complex chemical reactions involving sunlight and atmospheric compounds, though Jupiter is not alone in space. It is surrounded by an incredible family of more than 90 known moons, effectively forming a mini solar system. Among these, the 4 largest, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, discovered by Galileo Galilei in 1610. Io is the most volcanically active body in the solar system, with hundreds of erupting volcanoes. Europa is of particular interest to scientists because it is believed to harbor a subsurface ocean, making it one of the most promising places to search for extraterrestrial life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and it possesses its own magnetic field. Callisto is heavily cratered and may also contain an underground ocean. These moons provide valuable insights into planetary formation and the potential for life. What if there were a planet so massive that it could swallow every other planet in our solar system and still have room to spare? A world with storms larger than Earth, a magnetic field powerful enough to trap deadly radiation, and dozens of mysterious moons. Welcome to Jupiter, the undisputed king of our solar system. Unlike Earth, Jupiter is a gas giant, meaning it doesn't have a solid surface. Instead, it is primarily composed of hydrogen and helium, similar to the Sun. As you move deeper into the planet, the pressure becomes so intense that hydrogen transforms into a strange state known as metallic hydrogen, capable of conducting electricity. At its core, scientists believe there may be a dense, rocky or icy center, although this is still a topic of ongoing research. The extreme conditions within Jupiter make it impossible for any spacecraft or human to land on it. Any attempt to descend into its atmosphere would result in being crushed by immense pressure and vaporized. Jupiter possesses the strongest magnetic field of any planet in our solar system, about 20,000 times more powerful than Earth's. This magnetic field creates an enormous region of charged particles known as the magnetosphere, which extends millions of miles into space. This powerful environment generates spectacular auroras near Jupiter's poles, far more intense than those seen on Earth. However, the radiation trapped within this magnetosphere is extremely dangerous, posing significant challenges for spacecraft. NASA's Juno mission, launched in 2011, was specifically designed to withstand this harsh environment while studying Jupiter's interior and magnetic. Jupiter is the largest planet in our solar system, a true giant that dominates the space around it. Located about 484 million miles, or 778 million kilometers from the Sun, this gas giant has fascinated astronomers for centuries. Named after the king of the Roman gods, Jupiter lives up to its name with its immense size, powerful gravity, and majestic presence. If Jupiter were hollow, more than 1,300 Earths could fit inside it. Despite its enormous size, Jupiter spins incredibly fast, completing one full rotation in just about 10 hours, making it the fastest spinning planet in the solar system. This rapid rotation gives Jupiter its distinctive striped appearance, formed by bands of clouds moving in opposite directions. While Saturn is famous for its stunning rings, Jupiter also has a faint ring system. Discovered in 1979 by NASA's Voyager 1 spacecraft, these rings are composed mainly of tiny dust particles created by impacts on Jupiter's small inner moons. Though not as visually spectacular as Saturn's rings, they add another layer of complexity. Jupiter is more than just a planet. It is a symbol of the immense power and mystery of our universe. From its colossal storms and powerful magnetic field to its fascinating moons and protective role, Jupiter continues to inspire scientists and dreamers alike. As we explore this giant world, we are reminded of how small our own planet is in comparison, and yet how fortunate we are to exist in a solar system shaped and safeguarded by this celestial king. The more we learn about Jupiter, the more we understand not only the universe around us, but also our place. So the next time you look up at the night sky, remember that beyond the twinkling stars lies Jupiter, the mighty guardian of our solar system, silently shaping the destiny of worlds. Jupiter's immense gravity plays a crucial role in protecting the inner planets, including Earth. Acting as a cosmic shield, Jupiter attracts and deflects comets and asteroids that might otherwise collide with our planet. A dramatic example of this occurred in 1994 when comet Shoemaker-Levy 9 collided with Jupiter, providing scientists with a rare opportunity to observe such an event and highlighting Jupiter's protective. A day on Jupiter lasts only 10 hours, but a year takes nearly 12 Earth years. Jupiter's gravity is 2.5 times stronger than Earth's. The planet emits more heat than it receives from the Sun. Jupiter's magnetosphere is the largest structure in the solar system. Ganymede, one of Jupiter's moons, is the largest. A common question is whether Jupiter could ever become a star. While it contains many of the same elements as the Sun, Jupiter would need to be at least 80 times more massive to initiate nuclear fusion in its core. Therefore, despite its grandeur, Jupiter will remain a planet, a magnificent one, but not a star. Jupiter has been the target of several groundbreaking space missions. The Pioneer and Voyager missions provided the first close-up images, while the Galileo spacecraft orbited Jupiter from 1995 to 2003, delivering invaluable data about the planet and its moons. Currently, NASA's Juno spacecraft continues to revolutionize our understanding of Jupiter. By studying the planet's gravity, magnetic field, and atmospheric composition, Juno has revealed that Jupiter's core may be fuzzy rather than solid, and that its atmospheric storms extend deep beneath the cloud tops. Looking ahead, future missions such as NASA's Europa Clipper and the European Space Agency's JUICE mission aim to explore Jupiter's icy moons in greater detail, particularly in the search for signs of life. If you enjoyed this incredible journey through our solar system, don't forget to like this video and subscribe to Cosmic Secrets for more fascinating space stories. Here, we explore the mysteries of the universe, from distant planets and powerful black holes to the search for life beyond Earth. Share this video with fellow space enthusiasts and become part of our growing cosmic community. The universe is filled with endless wonders and hidden secrets, and this is just the beginning of our journey together. Stay curious, keep looking up, and join Cosmic Secrets as we continue to uncover. Right now, as you're watching this video, engineers, scientists, and billionaires are spending billions of dollars trying to get humans to one single destination. Not the moon, not some distant galaxy, Mars. But here's what they don't tell you in school. Mars isn't just a red rock floating in space. It's a world with ancient volcanoes, frozen oceans, deadly dust storms, and possibly the next home for the human race. Stay with me, because by the end of this video, you'll look at the night sky completely differently. Section 1. What is Mars? Mars is the fourth planet from the Sun, sitting about 142 million miles away from it. It's named after the Roman god of war, and honestly, that name fits. Mars is violent, extreme, and unforgiving. It's roughly half the size of Earth, but don't let that fool you. The total land area on Mars is actually similar to Earth's landmass because Mars has no oceans covering it. Every inch of Mars is raw, exposed terrain. A Martian day, called a sol, is 24 hours and 37 minutes. So if you woke up on Mars, your morning routine would feel almost normal. But a Martian year? That's 687 Earth days. 2 full years would pass on Earth before Mars even completes one trip around the Sun. And the gravity on Mars is only 38% of Earth's gravity. That means if you weighed 180 pounds here, you'd weigh just 68 pounds on Mars. You could literally jump 3 times higher than you can right now. Sounds fun until you realize the atmosphere is 95% carbon dioxide. One breath outside without a suit, and you'd be dead in minutes. Section 2. The extreme terrain. Mars is home to some of the most extreme geography in the entire solar system. Let's start with Olympus Mons, the largest volcano ever discovered. It stands 16 miles high. That's nearly 3 times the height of Mount Everest. It's so wide that if you stood at its base, the peak would be beyond your horizon. You wouldn't even know you were standing on a volcano. Then there's Valles Marineris, a canyon system that stretches over 2,500 miles long and drops 5 miles deep. The Grand Canyon could fit inside Valles Marineris like a small ditch. This isn't just one of the biggest geological features on Mars, it's one of the largest in the entire known solar system. Mars also has polar ice caps, just like Earth, but instead of only water ice, the Martian poles contain dry ice, frozen carbon dioxide. In winter, these caps grow massive. In summer, they shrink as the carbon dioxide evaporates back into the thin atmosphere. And then there are the dust storms. Mars is famous for them. These aren't gentle breezes. Global dust storms on Mars can engulf the entire planet for months at a time, blocking sunlight and dropping temperatures even further. NASA's Opportunity rover, which was designed to last 90 days, actually survived for 15 years until one of these massive dust storms. Section 3. Water, the biggest mystery. Here's where things get truly mind-bending. Scientists have found overwhelming evidence that Mars once had liquid water, rivers, lakes, and possibly even a shallow ocean covering its northern hemisphere billions of years ago. We're talking about a planet that may have once looked a lot like Earth. Ancient riverbeds and lake basins have been photographed by Mars orbiters. Minerals that only form in the presence of liquid water have been discovered on the surface. And beneath the south polar ice cap, radar data strongly suggests there's a liquid saltwater lake buried miles underground, even today. That's not nothing. That is potentially everything. Because where there is water, there is the possibility of life. No one is saying little green men, but microbial life, bacteria, extremophiles, organisms that survive in the harshest conditions may have existed on Mars in its ancient past, and some scientists believe they might still exist underground, shielded from radiation, clinging to whatever warmth and moisture is left. We haven't confirmed it yet, but we haven't ruled it out either. Section 4. The Race to Mars. Humans have been fascinated with Mars for centuries, but in the last decade, that fascination has turned into a full-blown global race. NASA's Perseverance rover, which landed in February 2021, is currently exploring Jezero Crater, an ancient lakebed. It's drilling into rocks, collecting samples, and looking for signs of ancient microbial life. It has already made history by producing oxygen from the Martian atmosphere, a breakthrough for future human missions. China landed its own rover, Zhurong, on Mars in 2021, making it only the second country to successfully operate a rover on the Martian surface. And then there's Elon Musk and SpaceX, who have stated their goal clearly: make humans a multi-planetary species. SpaceX's Starship rocket is being built specifically for Mars. Musk has publicly said he wants to put humans on Mars within this decade, and he means it. The plan? Send cargo missions first, build infrastructure, establish fuel production using Martian resources, then send humans. It's not science fiction anymore. It is an active, funded engineering project happening right now. Let's be honest about something that most Mars hype videos completely skip over. Mars is trying to kill you in multiple ways, simultaneously. First, radiation. Earth has a magnetic field that shields us from deadly solar and cosmic radiation. Mars lost its magnetic field billions of years ago. That means the Martian surface is constantly bombarded by high-energy radiation from the sun and deep space. A single year on Mars would expose a human to radiation levels far beyond safe limits, dramatically increasing the risk of cancer, organ damage, and cellular breakdown. You can't just walk around on Mars. You'd need to live underground or inside heavily shielded habitats for most of your life. Second, the temperature. Mars is brutally cold. The average surface temperature is around -80 degrees Fahrenheit. At the poles in winter, it can plunge to -220 degrees. Even on a warm summer day near the equator, temperatures might briefly hit 70 degrees Fahrenheit, but then crash back below freezing after sunset. No insulation on Earth prepares you for that kind of daily temperature swing. Third, the pressure. The atmospheric pressure on Mars is less than 1% of Earth's. That's thinner than the air at the top of Mount Everest, and Everest can already kill an unprepared climber. On Mars, without a pressurized suit or habitat, your blood would literally begin to boil. Not from heat, but because the pressure is so low that liquids vaporize at body temperature. Fourth, perchlorate. The Martian soil contains toxic chemicals called perchlorates, salts that are harmful to human health and would contaminate any food grown in unprocessed Martian dirt. Before any farming could happen, the soil would need to be chemically treated and neutralized. This isn't meant to scare you away from Mars. It's meant to show you the scale of the engineering challenge we're actually facing. Every single one of these problems has a potential solution, but none of them are easy, and none of them are cheap. The people who go to Mars first will be some of the most courageous, disciplined, and prepared. Right now, if this video blew your mind, smash that like button and subscribe, because we're covering the... What if you had the power to go back in time, but only for 1 hour, and whatever you changed could destroy everything? It started on a cold night in Chicago. Ethan Cole wasn't a hero. He wasn't even someone people noticed. A quiet physicist, working late hours in a forgotten laboratory, chasing a theory most scientists called impossible: time travel. For years, Ethan believed time wasn't a straight line, but a loop, a fragile system that could be bent just slightly without breaking. And on that night, after countless failed attempts, he finally did it. The machine hummed softly. Blue light flickered across the room. His heart pounded as he stared at the digital timer on the screen. Temporal jump, 60 minutes. 1 hour into the past. Nothing more, nothing less. Ethan hesitated. This wasn't just science anymore. It was power. But then his phone buzzed. A news alert. Massive accident on I-90 highway. 12 dead. His eyes froze on the screen. He recognized the time. It hadn't happened yet. Without thinking, Ethan stepped into the machine. A blinding flash. Silence. Then, the hum of traffic. The world snapped back into place. He was standing outside the lab 1 hour earlier. Cars rushed by. People walked normally. The world, unaware of what was coming. Ethan checked his watch. 59 minutes. He ran. The highway wasn't far. As he reached the scene, everything looked normal. Too normal. No chaos, no sirens. Just life. But Ethan knew. Somewhere in the next hour, something would go horribly wrong. He scanned every car, every movement, every detail. Then he saw it. A black SUV. Driving slightly off, swerving. The driver looked distracted, or worse. Ethan's pulse raced. He had to stop it. He ran onto the road, waving his arms. Cars honked. The SUV slowed slightly, then swerved again. Something wasn't right. Ethan moved closer, trying to see inside, and that's when he noticed. The driver wasn't unconscious. He was staring straight ahead, unblinking, almost lifeless. A chill ran down Ethan's spine. This wasn't just an accident. Something else was happening. Suddenly, a loud crash echoed behind him. Another car lost control, smashing into the divider. Panic spread instantly. Ethan turned back, and in that moment, the black SUV sped up, straight into traffic. The explosion of metal and glass was deafening. Cars collided, flames erupted, people screamed. It happened exactly as the news had said. Ethan stood frozen. He'd failed. Even with time travel, he couldn't stop it. The world glitched, reality twisted, and in a flash, he was back in the lab. Ethan fell to his knees, breathing heavily. The machine beeped. Jump complete. But something was wrong. The news on his phone changed. Highway crash claims 18 lives. Ethan's heart dropped. He made it worse. That's when he realized the truth. Time wasn't meant to be changed. Every attempt had consequences. But Ethan wasn't ready to give up. He reset the machine. Again, and again, and again. Each jump, another attempt. Each attempt, another failure. Sometimes the crash happened earlier. Sometimes it happened differently, but it always happened. And every time, more people died. Ethan started noticing patterns, small details repeating, moments that felt familiar, like time was resisting him. Then one jump changed everything. Ethan arrived earlier than before. This time, he followed the SUV before it reached the highway. He needed to know why. The vehicle turned into a quiet street, slowed down, and stopped. Ethan approached cautiously, heart pounding. He looked inside and froze. The driver was him. Same face, same eyes, but older, tired, broken. Ethan stepped back, shaking. This isn't possible. The older version of him looked up slowly, as if he knew, as if he'd been waiting. "You finally figured it out," the older Ethan said. "What is this? What's happening?" The older Ethan sighed. "I tried to stop it too." "How many times?" Ethan asked. The older version looked away. "I lost count." Ethan's mind raced. This doesn't make sense. Why does the crash keep happening? The answer came quietly. Because we cause it. Silence. Every attempt to stop the accident created it. Ethan stepped back in horror. No, that's not possible." The older Ethan said, "You stepping into the road, the panic, the chain reaction, it all starts with you." The truth hit like a wave. He wasn't saving lives. He was the reason they were lost. Tears filled Ethan's eyes. "Then how do we stop it?" The older version looked at him with a sadness that felt endless. "You don't." Ethan shook his head. "There has to be a way." The older Ethan stepped out of the car, slowly, weakly. "I spent years trying to fix it. Every possibility, every outcome." "And?" Ethan whispered. "There's only one way." Ethan held his breath. The older version looked him straight in the eyes. "You never build the machine." Silence fell, heavy, final. Ethan's world shattered. Everything he worked for, everything he believed, gone. "If you never create it," the older Ethan continued, "you never go back, and the accident happens naturally, with fewer casualties." Ethan clenched his fists. "So people still die?" "Yes, but fewer." Tears rolled down Ethan's face. This wasn't a victory. It was a sacrifice. The older version smiled faintly. "I couldn't do it. Could you?" The timer on Ethan's watch blinked. 0001. Time was running out. Ethan looked at the lab in the distance, at the machine, at everything he ever wanted. Then he looked back at himself, at the cost, and made his choice. The world flashed. Ethan was back in the lab, one final time. He walked slowly to the machine, ran his hand across it, memories flooding his mind. Then he pulled the power. The machine shut down forever. The next morning, the news reported a highway accident. 6 people dead. Tragic, but not catastrophic. Ethan sat in silence, knowing the truth. He could have saved more, but in trying, he almost destroyed everything. Sometimes, the greatest power is knowing when not to use it.
For thousands of years, people have looked at the sun as the source of life on Earth. It gives us light, warmth, and the energy that makes our planet habitable. Every sunrise reminds us of its importance. But what if the same star that makes life possible also has the power to disrupt modern civilization? It may sound surprising, but scientists have spent decades studying a hidden threat that doesn't come from Earth at all. It comes from nearly 93 million miles away, on the surface of the sun. The sun is far from being a quiet ball of fire. Deep inside, enormous forces are constantly at work. Powerful magnetic fields twist, collide, and build up incredible amounts of energy. Most of the time, these changes happen without affecting our daily lives. But occasionally, that energy is released in an explosive event unlike anything humans can create. These eruptions are known as solar storms. Some solar storms are relatively small and pass by with little effect. Others are powerful enough to send massive clouds of electrically charged particles racing through space at extraordinary speeds.
If one of those clouds is directed toward Earth, it can interact with our planet's magnetic field and trigger what scientists call a geomagnetic storm. This is not a theory. It is a natural phenomenon that has been observed and recorded many times throughout history. In fact, space agencies such as NASA and NOAA continuously monitor the sun every day, tracking solar activity and issuing forecasts whenever significant eruptions occur. Why? Because modern society depends on technologies that can be influenced by space weather. Communication satellites, GPS navigation, radio systems, aviation, and electrical infrastructure all operate in an environment connected to space. Understanding solar activity helps scientists and engineers prepare for periods of increased solar activity and reduce potential disruptions. One historic example still attracts the attention of researchers today. In 1859, astronomer Richard Carrington observed an enormous solar eruption. Shortly afterward, Earth experienced the most powerful geomagnetic storm ever recorded, now known as the Carrington event. At the time, telegraph systems across parts of North America and Europe experienced significant disruptions. Operators reported electrical surges, and spectacular auroras appeared much farther south than usual. The world of 1859 was only beginning to use electrical communication. Today's world is far more connected. That is why scientists continue studying how future extreme solar storms might affect modern technology, and how better forecasting can help protect critical systems. Fortunately, Earth has a strong magnetic field that provides important natural protection, and engineers continue improving the resilience of satellites and power networks. Even so, the sun remains one of the most powerful objects in our solar system, and there is still much we are learning about its behavior. So, the real mystery isn't whether solar storms exist. We know they do. The question is, if an extreme solar storm, similar to the Carrington event, occurred in the modern era, how would America respond? And are we truly prepared for it?
To understand how a solar storm could affect Earth, we first need to look at what is happening on the surface of the sun. The sun is not a calm, steady sphere. It is an enormous ball of superheated plasma, where temperatures reach thousands of degrees on the surface and millions of degrees in its outer atmosphere. Beneath that glowing surface, powerful magnetic fields are constantly twisting, stretching, and colliding with one another. As these magnetic fields become unstable, they can suddenly snap and reconnect, releasing an extraordinary amount of energy in just a few moments. This explosion is called a solar flare. Sometimes, a solar flare is accompanied by something even larger, a coronal mass ejection, or CME. A CME is a gigantic cloud of plasma and magnetic energy launched into space. It can contain billions of tons of charged particles traveling at millions of miles per hour. Most CMEs miss Earth completely because they are ejected in different directions. But when one is aimed directly at our planet, scientists begin watching very closely. Fortunately, Earth is not defenseless. Our planet is surrounded by a magnetic field called the magnetosphere. It acts like a giant invisible shield, deflecting much of the charged energy coming from the sun. Without this natural protection, life on Earth would face a much harsher environment. When a powerful CME reaches Earth, it doesn't strike the ground like a meteor. Instead, it collides with a magnetosphere, creating what scientists call a geomagnetic storm. These storms can produce spectacular displays of the northern lights, known as the aurora borealis. During strong solar activity, these colorful lights can sometimes be seen much farther south than usual, creating breathtaking scenes across parts of North America. But alongside this beauty, geomagnetic storms can also create challenges for technology. Strong disturbances in Earth's magnetic field can interfere with satellite operations, radio communications, GPS accuracy, and some power transmission systems. Airlines flying near the polar regions may occasionally adjust their routes during periods of intense solar activity to reduce communication disruptions. This is one reason why organizations such as NASA, NOAA, and the Space Weather Prediction Center monitor the sun around the clock. Using satellites and advanced instruments, scientists can often detect major eruptions and provide advance warnings before their effects reach Earth. Although forecasting has improved dramatically over the past few decades, predicting the exact strength and impact of a solar storm remains a complex scientific challenge. Every eruption behaves differently. Some pass with almost no noticeable effects. Others remind scientists just how dynamic and unpredictable our nearest star can be. As technology becomes more advanced and more connected to satellites and electrical systems, understanding space weather is becoming increasingly important. The sun has shaped life on Earth for billions of years. But it also reminds us that even from 93 million miles away, events in space can influence the technology we depend on every day. In the next part, we'll explore what scientists believe could happen if an extreme solar storm, comparable to the historic Carrington event, struck the modern United States. If an extreme solar storm were directed toward Earth today, it would not arrive without warning. Unlike an earthquake or a tornado, scientists can often detect major solar eruptions while they are still traveling through space. During that time, space weather experts analyze satellite data, estimate the storm's strength, and issue alerts to governments, power companies, satellite operators, and aviation authorities. Preparation is one of the biggest advantages modern society has over previous generations. When a strong solar storm approaches, satellite operators can place spacecraft into protective modes to reduce the risk of damage. Power companies may take steps to reduce stress on sections of the electrical grid, while airlines can adjust routes if necessary. Scientists also monitor astronauts aboard the International Space Station, since they are more exposed to space radiation than people on Earth's surface. Even with these precautions, an exceptionally powerful solar storm would still present significant challenges. The United States relies on thousands of satellites orbiting Earth. These satellites support weather forecasting, navigation, television broadcasting, emergency communications, scientific research, and many other services used every day. A severe geomagnetic storm could temporarily interfere with some satellite operations or communications. Engineers design many spacecraft with protective systems, but no technology is completely immune to extreme conditions in space. Electrical infrastructure is another area of concern. Large power grids stretch across thousands of miles, carrying electricity between cities and states. During intense geomagnetic storms, electrical currents can be induced in long transmission lines. Engineers have studied this effect for decades and continue improving protective equipment to reduce potential risks. Scientists emphasize that not every solar storm causes widespread disruption. Most solar activity produces only minor effects, and many events pass without noticeable consequences for the general public. The level of impact depends on several factors, including the strength of the eruption, its magnetic orientation, and how directly it interacts with Earth's magnetic field. One reason researchers continue studying solar storms is that our dependence on technology continues to grow. From communication networks and navigation systems to weather satellites and scientific instruments, modern civilization is more connected to space than ever before. Understanding space weather helps governments and industries improve resilience and make better decisions when significant solar activity occurs. Despite the challenges these storms may present, they also reveal something extraordinary about our planet. Earth's magnetic field has protected life for billions of years, shielding us from much of the sun's harmful radiation. Without this invisible magnetic shield, life as we know it would be dramatically different. Solar storms remind us that space is not empty or inactive. It is a constantly changing environment, where even our nearest star continues to shape conditions throughout the solar system. The sun is both the source of Earth's energy and one of nature's most powerful forces. Studying its behavior is not simply about predicting beautiful auroras or protecting technology. It is about understanding the dynamic relationship between our planet and the star that has sustained life for billions of years. Although extreme solar storms are rare, they remain one of the most closely monitored natural hazards in space. Every day, scientists use advanced satellites and solar observatories to watch the sun, tracking changes in its magnetic activity and searching for signs of major eruptions before they reach Earth. Over the years, researchers have developed better forecasting systems, stronger satellite designs, and improved methods for protecting critical infrastructure. These advances have greatly increased our ability to prepare for severe space weather. At the same time, the sun continues to remind us that nature is far more powerful than the technology we create. Even after decades of scientific research, many questions about solar activity remain unanswered. Every new mission launched to study the sun brings us closer to understanding how our nearest star truly works. Whether the next major solar storm happens next year or many decades from now, one thing is certain. Space weather will continue to be an important part of our future. The sun has shaped Earth for billions of years, and its influence reaches far beyond the light we see every day. Understanding that connection helps us prepare for tomorrow, while revealing just how remarkable our place in the universe truly is. The sun has powered life on Earth for billions of years, but it also reminds us that space is full of powerful natural forces we are still learning to understand. Scientists continue monitoring solar activity every day, improving forecasts and developing better ways to protect modern technology. While extreme solar storms are rare, their potential impact makes them an important area of research. As our world becomes more connected through satellites and advanced technology, understanding space weather is more important than ever. The next great solar storm may be years away, or it could arrive sooner than we expect. What if I told you James Webb just revealed something that could change everything we know about the universe? For decades, astronomers believed the early universe was simple, dark, and mostly empty. But then, the James Webb Space Telescope looked deeper into space than ever before, and what it found shocked scientists. Webb detected massive, fully formed galaxies that appear to have existed far earlier than many current models predicted. These galaxies seem too large and too evolved for such an early stage of the universe. Because light takes billions of years to reach us, looking farther into space is like looking back in time. That means James Webb is showing us the universe as it existed billions of years ago. Some of these observations are encouraging scientists to re-examine parts of our understanding of how galaxies formed. Could our current theories need updates? Or are there cosmic processes we haven't discovered yet? James Webb isn't proving that everything we know is wrong, but it is opening new questions that astronomers are actively investigating. Every new image from Webb reminds us that the universe is far more mysterious than we imagined. The greatest discoveries may still be waiting in the darkness. What if everything we know about the universe is incomplete? James Webb discovered ancient galaxies that shouldn't exist so early, forcing scientists to rethink how our universe may have truly begun. These galaxies appear surprisingly massive and mature for such an early point in cosmic history. Because James Webb looks billions of years into the past, every observation challenges scientists to test and refine existing theories. The telescope isn't rewriting science, it's revealing mysteries that could reshape our understanding of the universe.
As researchers continue analyzing James Webb's data, they're uncovering objects that formed only a few 100 million years after the Big Bang. Some of these galaxies contain far more stars than scientists expected, raising new questions about how quickly the early universe evolved. While these findings don't disprove the Big Bang, they suggest parts of our current models may need refinement. That's how science works. New evidence leads to better understanding. With every deep space image, James Webb pushes the limits of human knowledge, reminding us that the universe is still full of hidden secrets waiting to be discovered, beyond the reach of our imagination.
What if everything we know about the universe is incomplete? James Webb discovered ancient galaxies that shouldn't exist so early, forcing scientists to rethink how our universe may have truly begun. These galaxies appear surprisingly massive and mature for such an early point in cosmic history. Because James Webb looks billions of years into the past, every observation challenges scientists to test and refine existing theories. The telescope isn't rewriting science, it's revealing mysteries that could reshape our understanding of the universe. As researchers continue analyzing James Webb's data, they're uncovering objects that formed only a few 100 million years after the Big Bang. Some of these galaxies contain far more stars than scientists expected, raising new questions about how quickly the early universe evolved. While these findings don't disprove the Big Bang, they suggest parts of our current models may need refinement. That's how science works. New evidence leads to better understanding. With every deep space image, James Webb pushes the limits of human knowledge, reminding us that the universe is still full of hidden secrets waiting to be discovered, beyond the reach of our imagination. Scientists expected darkness, but James Webb found ancient galaxies shining far too soon. If these observations are confirmed, they could transform how we understand the universe's earliest moments forever. Scientists thought they understood the early universe until James Webb looked deeper than ever before. Instead of finding tiny, newborn galaxies, Webb spotted enormous, fully developed galaxies that seemed to exist far too early after the Big Bang. The discovery stunned astronomers and sparked new debates across the scientific community. Are our current models missing something important? Or did galaxies form much faster than anyone imagined? James Webb hasn't proven that everything we know is wrong, but it has revealed mysteries that scientists are racing to solve. One telescope is rewriting our questions about the origins of the universe. What if the oldest galaxies in the universe are breaking the rules of modern science? For decades, astronomers believed they had a solid understanding of how the universe evolved after the Big Bang. Tiny clouds of gas slowly formed the first stars, then small galaxies, and eventually the giant galaxies we see today. It was a logical timeline, until the James Webb Space Telescope looked deeper into space than any telescope ever had. What it found surprised scientists around the world. James Webb has detected massive galaxies that already appear fully formed only a few 100 million years after the Big Bang. According to many existing models, galaxies that large and mature shouldn't have had enough time to develop. Because light takes time to travel, every distant object Webb observes is actually a snapshot from the ancient universe. Looking farther into space means looking farther back in time. In some cases, James Webb is showing us light that has traveled for more than 13 billion years before reaching Earth. The surprising part isn't just that these galaxies exist, it's how advanced they appear. Some contain enormous numbers of stars packed into structures that seem far older than scientists expected for that point in cosmic history. Researchers are now carefully analyzing these discoveries using spectroscopy, a technique that studies light to estimate the distance, composition, and age of galaxies. While some measurements are still being refined, the observations are encouraging astronomers to test and improve existing theories about galaxy formation. Importantly, James Webb has not disproven the Big Bang. Instead, it is providing new evidence that may help scientists better understand what happened in the universe's earliest moments. This is how science progresses. New observations lead to better models and deeper understanding. Every major discovery raises new questions. How did these galaxies grow so quickly? Were stars forming much faster than expected? Or are there physical processes in the early universe that researchers have not yet fully understood? Scientists around the world are working together to answer these questions, and every new Webb observation adds another piece to one of the greatest puzzles in astronomy. What if the universe has been hiding a secret that could transform everything we thought we knew about cosmic history? After the Big Bang, tiny clouds of hydrogen and helium slowly collapsed under gravity. The first stars ignited, small galaxies formed, and over billions of years, those galaxies merged into the enormous cosmic cities we see today. It was one of the strongest ideas in modern astronomy. Then, the James Webb Space Telescope looked farther into space and farther back in time than any observatory in human history. What it found left scientists asking brand new questions. Because light travels at a finite speed, every object James Webb observes is a glimpse into the distant past. Looking billions of light years away is like opening a window into the universe just a few 100 million years after the Big Bang. Astronomers expected to find tiny, young galaxies, still in the earliest stages of growth. Instead, Webb discovered galaxies that appear surprisingly massive, bright, and well-developed. Some seem packed with billions of stars far earlier than many existing models predicted. The discovery doesn't mean science was wrong. It means nature may be more complex than we imagined. Scientists are now carefully studying these galaxies using spectroscopy, a powerful technique that analyzes light to estimate a galaxy's distance, chemical composition, motion, and age. As more data becomes available, researchers are refining their measurements and testing new explanations for how these enormous structures formed so quickly. Several possibilities are being explored. Perhaps stars formed much faster in the young universe than expected. Maybe galaxies merged together at extraordinary speeds. Or perhaps physical processes that shaped the first galaxies worked differently during the universe's earliest moments. Every new observation helps scientists improve their understanding. Importantly, James Webb has not disproven the Big Bang theory. Instead, its discoveries are helping astronomers refine models of galaxy formation and better understand the universe's first few 100 million years. That's exactly how science advances. Every unexpected discovery leads to better questions, stronger evidence, and more accurate theories. The James Webb Space Telescope is doing far more than taking beautiful pictures. Its giant gold-coated mirror collects incredibly faint infrared light that has traveled across space for more than 13 billion years, allowing humanity to observe some of the earliest chapters in cosmic history with unprecedented detail. Each new image reveals galaxies, stars, black holes, and mysterious structures that were completely invisible to previous generations of telescopes. With every observation, Webb reminds us that the universe is still filled with mysteries waiting to be explored. Some answers may confirm what scientists already believe. Others could reveal entirely new chapters in the story of cosmic evolution. And that's what makes this mission so extraordinary. We are witnessing discoveries in real time, discoveries that future generations may one day read about in history books. One thing is certain. The deeper James Webb looks into the universe, the more it reveals that space is far stranger, more beautiful, and more mysterious than anyone ever imagined. And somewhere in that endless darkness, the next discovery may be waiting to change everything. But the mystery doesn't end with ancient galaxies. James Webb has also detected surprisingly bright objects, massive star-forming regions, and distant structures that seem to have evolved far faster than many scientists expected. These discoveries are encouraging astronomers to re-examine how the first galaxies grew during the universe's earliest era. One possibility is that the first generations of stars formed at an incredible rate, producing galaxies much more rapidly than current models predicted. Another idea suggests that early galaxies merged together more efficiently, creating large cosmic structures in a surprisingly short amount of time. Researchers are actively testing these possibilities, using new observations and advanced computer simulations. What makes James Webb's discoveries even more remarkable is that every answer seems to uncover an even bigger mystery. Beyond ancient galaxies, Webb has detected extremely distant black holes, unusual star clusters, and faint galaxies that challenge our understanding of the early universe. Some of these objects appear to have grown much faster than scientists once believed was possible. Astronomers are now exploring whether the conditions after the Big Bang were more favorable for rapid galaxy formation than previously thought. Others are investigating whether hidden processes, still unknown to modern science, helped shape the universe during its earliest moments. Every new observation is carefully compared with data from other observatories, allowing researchers to test ideas with greater accuracy than ever before.
James Webb isn't rewriting the laws of physics overnight. Instead, it's providing the most detailed view of the young universe humanity has ever seen. With each new image, scientists gain another clue in the search to understand where galaxies, stars, and even our own cosmic origins came from. The deeper Webb peers into space, the more it reminds us that the universe is still full of unanswered questions. And somewhere in that endless darkness, the next discovery could reveal a chapter of cosmic history we've never imagined before.
Every new transmission from James Webb reminds us that the universe is still writing its own story. What once seemed impossible is now becoming a new frontier of discovery. The greatest cosmic secrets may still be waiting, hidden in the darkness, billions of light years beyond our reach. As James Webb continues exploring the deepest corners of space, every observation brings humanity closer to understanding our cosmic origins. The universe has guarded its secrets for billions of years, but now, for the first time, we're beginning to unlock them, one extraordinary discovery at a time. What if the universe has been hiding something that shouldn't exist? For decades, scientists believed they had a reliable timeline for how the universe evolved after the Big Bang. Tiny clouds of hydrogen gradually formed the first stars, those stars gathered into small galaxies, and over billions of years, those galaxies slowly grew into the enormous cosmic cities we see today. Then James Webb looked deeper than any telescope in human history. And suddenly, that timeline didn't seem so certain anymore. Using its powerful infrared instruments, the James Webb Space Telescope has detected galaxies that appear astonishingly massive, bright, and surprisingly mature only a few 100 million years after the Big Bang. According to many existing models, these galaxies simply shouldn't have had enough time to become so large. Because light travels at a finite speed, every distant galaxy is actually a message from the past. When James Webb observes objects more than 13 billion light-years away, it's showing us the universe as it existed near the beginning of cosmic history. But the biggest surprise isn't just their age, it's how developed these galaxies already appear. Some contain billions of stars packed into organized structures, suggesting that galaxy formation in the early universe may have happened much faster than researchers once believed. Scientists are now carefully studying these discoveries using spectroscopy, which reveals a galaxy's distance, chemical composition, and physical properties with remarkable precision. These observations are encouraging astronomers to test long-standing theories in entirely new ways. Some researchers believe the first generations of stars may have formed at extraordinary speeds, rapidly building galaxies far earlier than expected. Others suggest frequent galaxy mergers could have accelerated their growth. There are also ideas involving hidden physical processes that scientists are only beginning to investigate. Importantly, James Webb has not disproven the Big Bang. Instead, it is giving humanity the clearest view ever obtained of the young universe, allowing scientists to refine existing models with better evidence. That's exactly how science advances, not by ignoring unexpected discoveries, but by investigating them. Every new observation raises another fascinating question. If galaxies formed faster than expected, what else might we be missing? Could the first black holes have grown more rapidly? Were the earliest stars unlike anything we've ever observed before? Or does the young universe still contain secrets waiting to completely transform our understanding of cosmic evolution? Astronomers around the world continue analyzing every new image, comparing Webb's discoveries with advanced computer simulations and observations from other space telescopes. Piece by piece, humanity is assembling one of the greatest puzzles ever explored. James Webb isn't just observing distant galaxies, it's allowing us to witness the earliest chapters of the universe itself. And the mission has only just begun. With every new discovery, Webb pushes the boundaries of human knowledge farther into the unknown, reminding us that the universe remains far more mysterious, complex, and breathtaking than we ever imagined. Somewhere beyond those ancient galaxies, another extraordinary discovery may already be waiting. The next image from James Webb could reveal a secret that changes our understanding of the cosmos forever. What if the oldest galaxies in the universe are forcing scientists to rethink everything they thought they knew? For decades, astronomers believed they had a clear picture of how the universe evolved after the Big Bang. According to the Standard Model, the first stars slowly formed from clouds of hydrogen and helium. Those stars eventually gathered into small galaxies, which gradually merged over billions of years to create the massive galaxies we observe today. It was a timeline supported by decades of research. Then, the James Webb Space Telescope looked deeper into space than any telescope in human history.
And what it found stunned the scientific community. Instead of seeing only tiny, young galaxies in the early universe, Webb discovered massive galaxies that already appeared surprisingly bright, organized, and mature. Some of these galaxies existed only a few 100 million years after the Big Bang, a period when many scientists expected the universe to still be in its earliest stages of development. How could galaxies grow so quickly? That's the mystery researchers are now trying to solve. The James Webb Space Telescope is unlike any observatory ever built. Positioned nearly 1 million miles from Earth, at the Sun-Earth L2 point, Webb uses an enormous 6.5-meter gold-coated mirror and highly sensitive infrared instruments to detect incredibly faint light traveling across the universe.
Because light takes time to reach us, looking deeper into space is the same as looking farther back in time. Every distant galaxy Webb observes is a snapshot from billions of years ago. Some of the light reaching Webb today began its journey over 13 billion years before arriving at the telescope. In other words, James Webb is allowing humanity to witness the universe during its earliest chapters. But these ancient galaxies aren't behaving exactly as scientists expected. Several appear far larger and contain many more stars than current models predicted for that period of cosmic history. Rather than finding simple building blocks of future galaxies, astronomers are seeing structures that already look surprisingly well developed. That doesn't mean modern science is wrong. It means nature may be more complex than anyone imagined. Researchers are carefully analyzing every observation using spectroscopy, an advanced technique that separates light into its individual wavelengths. This allows scientists to estimate a galaxy's distance, chemical composition, temperature, motion, and age with incredible accuracy. Each new measurement provides another clue. Some astronomers believe the first generations of stars may have formed much faster than previously thought. If stars were born at extraordinary rates, galaxies could have grown far more rapidly than existing models predicted. Another possibility is that early galaxies collided and merged more frequently, accelerating their growth into massive structures within surprisingly short periods of time.
There are also theories suggesting that unknown physical processes may have influenced the early universe in ways scientists have not yet fully understood. Every possibility is being carefully tested. Importantly, James Webb has not disproven the Big Bang Theory.
In fact, Webb's discoveries strongly support many aspects of modern cosmology, while encouraging scientists to refine certain details about how galaxies formed and evolved after the Big Bang. That's exactly how science progresses, not by rejecting evidence, but by improving theories whenever new observations reveal something unexpected. History has shown that many of humanity's greatest discoveries began with surprising observations.
Every time scientists believed they understood the universe completely, nature revealed another mystery waiting to be solved. James Webb is continuing that tradition. Beyond ancient galaxies, Webb has also detected distant black holes, massive star-forming regions, and faint objects never before observed by human eyes. Each discovery adds another piece to one of astronomy's greatest puzzles.
Astronomers around the world are now combining Webb's observations with powerful computer simulations, data from other observatories, and years of theoretical research to better understand how the earliest galaxies truly evolved. The answers may not come overnight. Some could take years. Others may take decades. But every image James Webb captures brings humanity one step closer to understanding our cosmic origins.
Perhaps the greatest lesson from Webb isn't that the universe is breaking the rules. It's that the universe still has rules we haven't discovered yet. Every new observation reminds us how little we truly know about the cosmos. The deeper we explore, the more mysteries appear beyond the horizon. James Webb isn't simply taking beautiful pictures of space.
It's acting as a time machine, revealing moments from the dawn of the universe that no human has ever witnessed before. And this extraordinary mission is only getting started. Somewhere in the darkness, billions of light years away, another ancient galaxy may already be waiting to challenge everything we think we know.
The next image from James Webb could become one of the greatest discoveries in the history of astronomy. Because in the universe, the biggest mysteries are often the ones we never expected to find.
Yet every answer James Webb uncovers leads to even greater questions. Beyond the edge of the observable universe, countless mysteries may still remain hidden. As technology continues advancing, future discoveries could reveal chapters of cosmic history we've never imagined, bringing humanity closer than ever to understanding the true story of our universe.
Somewhere among those ancient galaxies, the next revolutionary discovery may already be waiting. Every deep space image captured by James Webb brings scientists closer to answering humanity's oldest questions. Until then, the universe continues reminding us that its greatest secrets are still hidden in the silent darkness of space.
The deeper James Webb explores the cosmos, the more it reveals how extraordinary our universe truly is. Every distant galaxy, every faint signal, and every unexpected discovery reminds us that humanity has only begun.
For centuries, humanity believed that the universe was largely predictable. Stars appeared fixed, galaxies seemed scattered across space, and the vast cosmos looked calm from our point of view. But as telescopes became more powerful and astronomers began measuring the motion of distant galaxies with greater precision, they uncovered something completely unexpected. The Milky Way isn't simply drifting through the universe. Instead, our galaxy is moving through space at an extraordinary speed, and it isn't traveling alone. Thousands of nearby galaxies appear to be heading in nearly the same direction. This motion cannot be explained by the expansion of the universe alone, leading scientists to one of the greatest cosmic mysteries ever discovered.
What could possibly be powerful enough to influence the movement of entire galaxies? The answer points toward a mysterious region known as the Great Attractor. Unlike a star or a planet, The Great Attractor cannot be observed directly with ordinary telescopes. It lies behind one of the most difficult regions of the sky to study, an area hidden by the dense stars, gas, and dust of our own Milky Way. Astronomers call this hidden region the zone of avoidance because it blocks much of our view of the distant universe.
Although the Great Attractor remains largely invisible, its presence is revealed through gravity. By carefully measuring the velocities of galaxies, scientists discovered that many are moving toward the same hidden location. This suggests the existence of an enormous concentration of mass, whose gravity influences an immense region of space. Current research places the Great Attractor roughly 150 to 250 million light-years from Earth, in the direction of the constellations Norma and Triangulum Australe. Rather than being a single object, astronomers believe it is associated with a vast collection of galaxy clusters, superclusters, and large amounts of dark matter working together through gravity. Even this may not be the end of the story.
More recent observations indicate that the Great Attractor itself could be part of an even larger network of cosmic structures, extending across hundreds of millions of light-years. One of the leading candidates influencing this region is the Shapley supercluster, among the most massive concentrations of galaxies ever identified. These discoveries reveal that the universe is organized on scales almost beyond imagination. Galaxies are not randomly scattered through space. They form enormous interconnected structures shaped by gravity over billions of years.
Every new observation helps astronomers build a clearer picture of this hidden cosmic web, yet many questions remain unanswered. The Great Attractor reminds us that some of the universe's most influential observatories, galaxy surveys, and computer simulations to understand the unseen mass guiding the motion of galaxies across the cosmos. Far beyond the reach of our solar system, an invisible gravitational giant continues to shape the journey of the Milky Way, making the Great Attractor one of the most fascinating mysteries in modern astronomy.
The discovery of the Great Attractor didn't happen because scientists saw a giant object in space. Instead, they found it by studying how galaxies move. During the 1970s and 1980s, astronomers began measuring the speed and direction of thousands of galaxies beyond the Milky Way. According to the expansion of the universe, galaxies should gradually move away from one another as space itself expands. This idea, first described by Edwin Hubble, has been confirmed through decades of observations. However, something unusual appeared in the data. Many galaxies were not moving exactly as expected.
Instead of following only the expansion of the universe, they showed an additional motion toward the same region of space. Astronomers call this motion peculiar velocity, the movement of a galaxy caused by gravity beyond the normal expansion of the universe. When researchers compared observations from different parts of the sky, they discovered that this wasn't happening to just a few galaxies. Entire galaxy groups, including our own local group, were drifting toward the same hidden region.
The local group contains more than 80 known galaxies, including the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. Together, this entire collection appears to be moving through space at roughly 600 kilometers per second toward the Great Attractor. This raised an extraordinary question. What kind of object could generate enough gravity to influence galaxies spread across hundreds of millions of light-years? Scientists quickly realized the answer could not be something ordinary.
No single star, black hole, or even one galaxy would have enough mass to create such an enormous gravitational pull. Instead, astronomers believe the Great Attractor represents an immense concentration of matter, made up of countless galaxies, massive galaxy clusters, hot intergalactic gas, and large amounts of dark matter, the mysterious substance that cannot be seen directly but is believed to make up most of the matter in the universe.
Although it does not emit, reflect, or absorb light, its gravity can still affect the motion of galaxies. By observing how galaxies move, scientists can estimate where invisible matter must exist, even if they cannot detect it directly. Another challenge is that much of the Great Attractor lies behind the Milky Way's zone of avoidance, where dense clouds of dust and billions of stars block our view. Traditional optical telescopes struggle to see through this region.
To overcome this obstacle, astronomers use radio telescopes, infrared observatories, and X-ray satellites capable of detecting objects hidden behind the dust. These instruments have revealed thousands of previously unseen galaxies, helping researchers build a better picture of this mysterious region. Even today, the Great Attractor remains one of astronomy's biggest puzzles. Each new observation provides another piece of the cosmic puzzle, revealing that the universe is far more interconnected than scientists once imagined. Rather than existing in isolation, galaxies are linked together through gravity on unimaginably vast scales, creating a hidden cosmic network that continues to shape the motion of our galaxy across the universe. One of the biggest questions surrounding the Great Attractor is surprisingly simple. If it has such an enormous gravitational pull, why can't we see it? The answer lies between Earth and the Great Attractor itself. Our solar system is located inside the Milky Way galaxy, and when astronomers look toward the Great Attractor, they must look directly through the crowded center of our own galaxy. That region is filled with billions of stars, vast clouds of gas, and thick layers of cosmic dust that block visible light. Because of this natural barrier, astronomers named the region the Zone of Avoidance. For many years, it was one of the least explored areas of the sky. Traditional optical telescopes simply couldn't see through the dense clouds hiding what lay beyond. But science didn't stop there. Instead of relying only on visible light, astronomers turned to advanced technology. Infrared telescopes can detect heat that passes through much of the dust, while radio telescopes observe radio waves that travel across the galaxy with far less interference. X-ray observatories also reveal extremely hot gas surrounding massive galaxy clusters, helping scientists identify structures that remain invisible in ordinary images. As these new observations accumulated, researchers began discovering something remarkable. Hidden behind the Milky Way were thousands of previously unknown galaxies. Many of them belonged to enormous galaxy clusters, connected by vast filaments of matter stretching across hundreds of millions of light years. Rather than existing as isolated islands, galaxies appeared to be part of a gigantic cosmic web linked together by gravity. The Great Attractor is believed to be located within one of these massive regions. However, modern research suggests that the story is even more complex. Astronomers now think the Great Attractor may not be the final destination of our galaxy's journey. Instead, it could be only one part of an even larger gravitational network extending across the universe. Beyond it lies the Shapley Supercluster, one of the most massive structures ever discovered. Containing thousands of galaxies, for centuries, humanity looked up at the night sky believing that space was quiet and unchanging. Stars seemed fixed in place, planets followed predictable paths, and the universe appeared calm. But modern astronomy has revealed a far different reality. Space is constantly in motion, and some of the most powerful objects ever discovered are completely invisible. Among them, nothing is more mysterious than a black hole. A black hole is not... Scientists have discovered black holes throughout our galaxy. Some formed from the collapse of massive stars after powerful supernova explosions. Others, called supermassive black holes, sit at the centers of galaxies and contain millions or even billions of times the mass of our Sun. At the center of the Milky Way lies Sagittarius A star, a supermassive black hole located about 26,000 light-years from Earth. Although it is unimaginably powerful, it is also unimaginably far away, posing no immediate danger to our solar system. But astronomy often begins with fascinating questions. One of the most intriguing
are
is
found
this.
at the center of
What would
nearly every
happen if a
galaxy.
black hole somehow
Dr.
entered
Dan
our
Evans,
solar system?
an
The
astrophysicist
answer
at
depends
NASA
on something
headquarters, says
surprisingly simple.
there's a direct
Its mass.
relationship between the
Many people
beginning of
imagine every
supermassive
black hole as a
holes and
gigantic
the beginning
cosmic
of their
monster,
corresponding
capable of
galaxy.
instantly
This
swallowing
strongly
planets.
suggests
In
the two
reality,
were born about
gravity
the same
depends on
time
mass and
and
distance,
slowly grew
not
in
whether an
size
object is a
together
black
over
hole.
billions of years.
For
With a
example,
mass
if the
equal to
sun
our
were
sun's,
magically
for
replaced
example,
by a black
you
hole
could
with
get as
exactly the
close
same
as
mass,
tens of miles.
Earth's orbit would remain
So
almost
imagine if we
unchanged.
replaced
Our planet
sun
would
with a black
continue
hole of the
traveling
same
around that
mass.
invisible object
All of
because the
planets would
gravitational pull
continue
would
to
be
revolve
nearly
around it
identical.
at exactly
The biggest
same
difference
speed
would not
and
be
distance
gravity.
as they
It
do
would be
now.
light. Without
Can escape
sunlight,
from a black
Earth would
hole.
quickly become a
One of
frozen
Stephen
world.
Hawking's
Temperatures would begin
contributions was a
falling
theory
dramatically
that a
as
black
plants
hole is
stopped
not so
producing
dense
energy through photosynthesis. Food chains would collapse, oceans would slowly freeze at the surface, and most life would struggle to survive. Deep underground and around hydrothermal vents, some organisms might continue living for much longer, but the planet would become almost unrecognizable. That scenario alone demonstrates an important scientific principle. Black holes are dangerous because of their gravity only when they come close enough.
Now imagine something even more dramatic. Suppose a wandering stellar mass black hole, perhaps 10 times the mass of our Sun, entered the outer regions of our solar system. At first, nothing unusual would be visible. Black holes emit no light of their own. Astronomers would likely discover it indirectly by measuring tiny changes in the motion of distant objects, or by detecting how its gravity bends the light of background stars, an effect known as gravitational lensing. As it moved closer, its gravity would begin disturbing the outer solar system. Objects in the distant Oort cloud could be knocked into new orbits. Some icy bodies might be sent toward the inner solar system, increasing the number of long-period comets over many years or even centuries. Eventually, the gravitational influence could extend farther inward. The orbits of Neptune and Uranus might begin changing by tiny amounts. These changes would be extremely difficult to notice at first, but astronomers using precise measurements would recognize that something unusual was happening.
Computer simulations show that even relatively small changes in planetary orbits can grow over long periods of time. Planets might experience altered orbits, asteroids could be redirected, comets could appear from unexpected directions. None of this would happen instantly. These changes would likely unfold over months, years, or much longer, depending on the black hole's path and speed. One of the greatest challenges would be predicting its exact trajectory.
Even small differences in its approach could produce dramatically different outcomes. If it passed far beyond Pluto, the effects might remain relatively limited. If it traveled through the inner solar system, the consequences could become far more significant. Earth's orbit might gradually become more elliptical. The length of our year could change. Seasonal patterns might shift. Climate could become increasingly unpredictable as our distance from the sun varied more dramatically. Meanwhile, other planets would also experience changing gravitational forces. Moons could be disturbed.
Asteroid belts could become unstable. Space itself would become a far more hazardous environment. Scientists emphasize that such a scenario is extraordinarily unlikely. The distances between stars are immense, making close encounters with black holes extremely rare. Even though our galaxy probably contains millions of stellar black holes, most remain thousands of light years away from us. Current astronomical observations show no evidence of a dangerous black hole approaching our solar system. Still, studying these possibilities helps researchers understand gravity, planetary motion, and the long-term evolution of cosmic systems. Black holes are more than science fiction monsters. They are natural laboratories where the laws of physics operate under the most extreme conditions known in the universe.
By observing them, astronomers continue testing Einstein's theory of general relativity, studying how stars evolve, and investigating mysteries that remain unsolved, including the true nature of gravity itself. The idea of a black hole entering our solar system captures the imagination because it combines real science with one of the universe's greatest unknowns. It reminds us that the cosmos is not only beautiful, but also filled with extraordinary objects whose behavior continues to challenge our understanding. Somewhere in the Milky Way, countless black holes drift silently through the darkness. Most will never come anywhere near Earth, but their existence is a reminder that the universe is far stranger, far larger, and far more mysterious than we once believed.
Scientists believe a black hole passing through our solar system is extraordinarily unlikely. Space is unimaginably vast, and the nearest known black holes are many light years away. But exploring this possibility helps researchers understand one of the universe's most powerful forces, gravity. If a wandering black hole ever entered our cosmic neighborhood, astronomers would probably detect unusual changes in the motion of distant objects long before it reached the inner solar system. Modern observatories, space telescopes, and sky surveys constantly monitor the heavens for unexpected movements and gravitational effects.
This thought experiment also reminds us how delicately balanced our solar system really is. Every planet follows a stable orbit because gravity keeps everything in harmony. A massive object entering that balance could reshape orbital paths over time, creating a completely different planetary system. Black holes remain among the greatest mysteries in astronomy. They challenge our understanding of physics, space, and time, and every new discovery brings scientists one step closer to understanding how our universe truly works.